Welcome back to BSLIVE Noding. In this episode, I want to show you these examples of how you can do like a stacking of random cube boxes with different sizes using simulation nodes. Okay, we have the first one, which is just random boxes, and each one of them is kind of stacked together. If I change the size of any of the boxes, however, you can see it's kind of adjusting accordingly. Okay, this is actually kind of interesting. It's really simple, but you need to get understand the basic first before you kind of try to do it using simulation nodes. So the other three is actually using simulation nodes. I just want to show you they're just gonna continue stacking the box forever and ever, depending on this frame. And then this guy is different from the other stack because of the different seed that I assign. So I can delete this. I can, if I duplicate this, run the simulations, they're gonna be the same. However, if I duplicate this one and then change the seed, see, it's totally different. It's just gonna keep going. The first one, however, doesn't use simulations, and let me explain how this works first. So the nodes looks really scary for the one that's actually, if you want to do this manually, right? You have 4 different boxes. This one is already grouped, the first one, and the second one is the same. This is like 4 same duplicates of the same object, and there's some transformation going on for each stack of the boxes, and this one is just joining everything into a single object. The first one, okay, let's start with one box. We have a simple box, and inside this, actually, you might have seen me using kind of similar setup in the past. Basically using bounding box to place an object on the floor. So it's kind of I started with a simple cube. I just make like a random size of cube here using this minimum and maximum. Okay, and I pipe the seed and the ID outside. So anyway, the cube will have random scale in XYZ. And the next thing I do here is just using bounding box and get the height of the boxes. So I'm subtracting the minimum and maximum of the bounding box, and then multiply this by 0.001. We just want to deal with the height, and then I divide it by 2, and so I know where to place the box at the bottom of the floor. You know, we just get the pivot at the bottom and just transform the geometry. So that's this, and then I pipe out the vector positions of the bottom of the box, so we know how much we can transform the next boxes. So if you want to stack boxes, the next boxes with different seed will be translated by the amount of the first box. So that's why this vector goes into this transform geometry and then goes in, and so on and so on. However, the next for the third box, so we know the first at the bottom of the floor, the second one stack, the second one get translated based on the height of the first box, and then the third one also the same, but using the vector of the first and the second. And then this one's gonna continue and accumulate itself. You see, there will be like some kind of pattern. If you want to have another boxes, we just duplicate this guy, right? Just randomize the seed, and we want to transform it, but we also want to add this guy and this guy, the vector, and then this goes into the translate. So box number 5 will be placed exactly where it's supposed to be. So it's a simple problem with stacking, and you can continue doing this manually. However, in our case, we want to use simulation nodes. So this is the simulation node method. It's much simpler, but what's going on inside here is similar to this manual way. However, they are inside simulation zone. Okay, they're inside simulation zone, and then this is our node group that's doing the magic with the bounding box. Just place it on the floor, basically. Place it on the floor, and then whatever vector height, simply pipe it out and then accumulate it using simulation zones. Whatever inside this will continue being accumulated. I have similar example in the previous video using, I think, using SVerchok or using geometry nodes as well. There's actually accumulate field here that can be used to do this stacking. It's just a different way of thinking, but I think the simulation setup over here is pretty cool. It's if you understand this, you kind of get some sort of ideas how you can use the same concept for different problem, right? It's really super basic, but however, we get this effect. Okay, duplicate it. I mean, if you want to make this one different and then this one also different, right? And then you want to make a lot of this. For this guy, just hold options and randomize the seed. Now we have 6 different stack of object. We cannot control how many stacks. I mean, they're being controlled, but the number of the boxes being controlled by the frame. In this case, in my other example, we can actually adjust the number of boxes. So it's kind of, each one of them has advantage. In this case, it's actually doing the simulations. There will be some advantage of you doing it this way, because it's simulation. There's probably at some point you can bend it, or you can maybe replace. You can potentially replace the boxes with any kind of objects. So just simply get the bounding box and you can stack the object. That way you can maybe replace it with Susan head, things like that. I haven't tried, but I could. Suzanne. Oh, we don't have Suzanne, but we can probably use UV sphere. But I need to consider the height. Maybe I won't do it today. But anyhow, we have this cube. We can randomize the vertices. You can actually boolean the whole thing. For example, if you have this single stack of this, and then you're done with this, right click, convert to mesh. Now this is becoming normal mesh. You probably want to boolean this, but you can perhaps use like shader cut, make random cut, and then you can randomly extrude it. And random, where is random? Select random. Oh, we want to select random faces. Select random faces, and then mesh, extrude faces along normal. Or actually mesh, extrude individual faces. And you can do the same thing again. Q, select random, and then extrude individual faces again. Repeat, select random, extrude individual faces. Yeah. just this sort of things that you can actually you can use simulation nodes to do the same thing. So select random, extrude individual, select random, extrude individual. Yeah, so that's just another example. You can try doing the same thing here, but next time use different objects. For example, that could work as well. Like I said, try also using cylinder. So instead of you having boxes, you can have cylinder. Although this box is also kind of interesting in itself. You can try the simulation instead of join geometry, maybe just boolean the whole thing. Mesh boolean union. Maybe I haven't tried this. This might work. Okay. Now this, if we subdivide, you can see it's a single mesh. It's already boolean properly. So that sort of thing. And here reduce the vertices, run the simulation again, convert to mesh, subdivide. You can see we have pretty unusual result there. And we don't finish here. In fact, you can always go inside the simulation node group here and randomize this value. Just go nuts. There, oops. There you go, right? It's really kind of a way to stack an objects, but also to build some kind of architectural concept. If you like, kind of like a blocky organic city or something. Right. We have a couple of these. Hold the options, randomize the seeds, so each one of them will be totally different again. There we go. Okay, so yeah, hopefully you find this useful. It's pretty basic, however, it's really powerful concept once you understand it. Yeah, hopefully this is useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.